Welcome to the final lesson of Section 4 in Unit 6. In this lesson, we have two videos that will be closely related. Hopefully, the idea of opposite operations is making sense in solving linear equations, because now we will bring things together as we look at solving equations of the form ax plus b equals c, where a, b, and c are whole numbers. Recall once again, to solve, we isolate the variable to determine its value. Addition and subtraction are opposite or inverse operations, as are multiplication and division. We will now examine linear equations of the form ax plus b equals c, where a, b, and c are whole numbers. We now have multiple operations occurring in our equations. The ax, that indicates a multiplied by x. The plus b, that indicates addition. So in this scenario, we must deal with the b value before we deal with the a value. This idea will become clearer when we look at a few questions. As we work through our first example, 2x plus 3 equals 7, and we solve for x, I want to revisit the algebra tiles, as this will make the algebraic process easier to follow. So with our algebra tiles, we would first represent 2x plus 3 equals 7. The two variable tiles for 2x, 3 unit tiles for plus 3, 7 unit tiles for 7. When we went through the process of solving using algebra tiles, if you recall, the first thing that we had to do was get rid of the unit tiles. And in this particular case, we could remove 3 from the left-hand side, which meant that we had to remove 3 from the right-hand side. Algebraically, we just translate that same idea into symbols. We have 2x plus 3, and what did we do first? We took away those 3 unit tiles, so subtract 3. And whatever I do to one side, I have to do to the other. So our first step in this process is to subtract 3 from both sides. When we go back to our algebra tiles, this then leaves us with our 2x, and now we have 4 unit tiles left on the right-hand side. Symbolically, it fits perfectly. Plus 3 minus 3, that goes away. We're just left with 2x. On the right-hand side, 7 subtract 3 is indeed 4. Back to our algebra tiles. Now we group one variable tile with 2 unit tiles, giving us x equals 2. Algebraically, when we have 2x equals 4, recall that 2x means 2 times x. The opposite of multiplication is division. So instead of 2 times x, I must divide both sides by 2. Whatever I do to one side, I must do to the other. 2x divided by 2, 2 divided by 2 is just 1, so we're left with 1x, or just x, and 4 divided by 2 is 2. X equals 2 is our solution. Let's verify. 2x plus 3, circle 7. In place of the x, we put what we found x to be, 2 plus 3, 7. Order of operations, we must do 2 times 2 first, which is 4. 4 plus 3, and 4 plus 3 is indeed 7. 7 equals 7. X equals 2 is our solution. Our second example, we have 6 plus 4n equals 22. We have to get n all by itself. We have to isolate it. If you wanted to, you could rearrange to give you 4n plus 6 equals 22. So you could, if you want, take those two terms on the left-hand side and rearrange them. Why would you do that? Well, some people like to have the variable term right out in front. I leave it up to you, but if you do rearrange, be sure to do so correctly. I will work with the form that I was given. So for the 6 plus 4n, I do know that I have to get rid of 6, or positive 6 first. To do that, I'm going to subtract 6. And if you want to visualize your unit tiles as you go along, that's fine. I'm removing 6 unit tiles from both sides. If I subtract 6 from the left-hand side, I must subtract 6 from the right-hand side. 6 minus 6, 0, left with 4n. 22 subtract 6 is 16. Now I have 4 times n equals 16. The opposite of multiplication is division. 4n divided by 4, and what I do to one side, I do to the other. So I've divided both sides by 4. 4 divided by 4 is just 1, leaving me with 1n, and 16 divided by 4 is 4. n equals 4. Let's verify. 6 plus 4n, 22. 6 plus, in place of the n, I put 4. Do the multiplication first, because that's what order of operations tells us to do. We get 6 plus 16, and 6 plus 16 is 22. Our solution checks out. And our final example, solve for w. 35 equals 20 plus 5w. This time, the variable has been placed on the right-hand side. Flip-flop idea, that could work. You can switch both sides and rearrange if you want to keep the variable term furthest to the left. Once again, I will work with the format that we've been given. I go over to the right-hand side because that's where my variable is 2. I have to deal with the 20 first. If you visualize your 20 unit tiles there, we need to get rid of those 20 unit tiles, which would mean that I would need to subtract 20. Whatever I do to one side, I must do to the other. So on the left-hand side, I have 35 subtract 20. Bottom line, you have subtracted 20 from both sides of your equation. Alrighty, 35 subtract 20 gives us 15. 20 subtract 20 is nothing. We're left with 5w. The right-hand side now, 5w means 5 times w. I need to do the opposite operation for multiplication, which is division. I need to divide by 5. And if I divide the right-hand side by 5, I must divide the left-hand side by 5. 5w divided by 5 will give me just 1w, and 15 divided by 5 is 3. So w equals 3. Let's verify. 35, circle 20 plus 5w. 35, 20 plus 5 times 3. 20 plus, do the multiplication, we get 15, and 35 certainly equals 35. The correct solution then for this particular linear equation is w equals 3. And now I'd like to proceed to the next video in this lesson.